I'm going to try to finish this up in this video. First, I want to drill some ventilating holes in the upper edge of this enclosure on each side. To do that, I've made a template that will, I hope, when I cut it out here, I'm going to split it in half. I'll tape this on to the side of the case, and I'll drill these holes. Just so you understand what I mean, I've taped this template neatly along the bottom, and I'm going to center punch a row of holes right here and then drill them. I intend to do some thermal measurements in and on this supply. I have two thermocouple readouts. All four thermocouples are in this little binder clip. And you can see this one's reading, they're all in centigrade, 16.4, 16.8. This one's reading 17.9 and 18. So let's call them all within 2 degrees C. And probably this is the shop temperature right now. I'm going to hook T1 on each of the meters to the inside of the case. The little handheld unit T1 is in the heat sink, and T1 on the bigger unit is tucked inside the transformer. Now I've drilled the cooling holes through the sides, and I'll fish the wires in through the holes. Here we are with the thermocouples installed. Wish I could see that. T1. T1 is inside the case on the transformer. T1 here is inside the case in the heat sink. T2 is going down in this heat sink on the back. I'm going to turn it on. It's 6:20 in the evening, and I've got the output shorted at 1.5 amps. Now unshorted, I've got it set at 10 volts, 11 volts. So I think I'll go putz around. I have some other things to do in the shop, and we'll come back and take a look at this a little later. So it's now 6:36, which would be 25 minutes later, and the shop is still at 18.5. This thermocouple, the white one, is going to the transformer, 34 degrees Celsius. This reading is the small heat sink inside, powering just actually the fans and the power light, which is an LED. And this is the heat sink in the back, which is insignificant, 50 degrees C is really nothing. So I'll run it up to, what the hell, go full blast, 3 amps. According to the analog meter, we're sitting at 3 amps. I would expect the only thing that's going to get hotter, is this heat sink. The one's at 56 degrees now. Transformer may get a little bit hotter, but at 3 amps, we're not taxing the transformers. Remember, each one's rated 2 amps. If they're splitting equally, and they probably are, it's only an amp and a half. Of course, the shops stand at 18, 18.8, 18.7. So this is a transformer. This is a small heatsink in the case. This is the big heatsink in the back with the fans on it. We'll call it 638. It's now 7:31. So we've been operating at 3 amps for a good amount of time now. The shop is still at 18.7. The transformer is at 53. The heat sink is at 47. That's a small internal heat sink. Is at 47. And the back heat sink is now at 76. And it's been sitting around 76 for about, well, I've been sitting here 10 minutes. I don't know how quickly it got there. It's essentially not moved. So thermally, I think that everything is fine. Here's a little power supply hooked to a 8 ohm 50 watt resistor, and that resistor is bridged by the yellow channel on the oscilloscope. I'm going to turn it on, and nothing happened except this lamp illuminated and the fans started. The load switch is 3 positioned. In the upper position, it powered the resistor up. That's 0. And that's on. I'll set the oscilloscope for a single trace, and we'll power the load. And some of that may be bounce in the switch. But most of it is because we are, as soon as I energize the load, I'm in the current limiting mode. The load switch is in the neutral position, so the load is not energized right now. If I push the load switch down, we can set the current. Of course, the current is in the current limiting position because what effectively I've done is shorted the output to the power supply. So I've increased the current limit to 2 amps. I've reset the oscilloscope. Now we're turning the load on, but we're not limiting the load at all. I'm going to turn the load off. And you see that's an off. I'll turn the load on. We're not current limited. Now we're doing a simple turn on. Here we are at 0. Here we are at 10 volts. Took 1, 2, 3, 4, 5 divisions, or 250 microseconds for the load to stabilize. That's under non-current current limiting power on situation. We'll look at it one more time. I've got it back in current limiting mode. I'll do a power on. I'm sorry, there's a power off. Power off. Now we'll do a power on. So we've got a decision-making period of time here for the power supply to decide what to do about this current limiting situation. Thermally, I left this thing run overnight at 3 amps into a dead short. I don't really think that glitch that's shown on the oscilloscope is much to worry about. Just be aware that it's a little bit funny. So if you're using this directly to power a digital circuit, you may get some problems on startup. So this wraps up our little power supply. I may go ahead and develop it using some ongoing information on the web, but I'll provide links to other discussion groups, the templates, and almost all of the interior components. If you've enjoyed this series, give me a thumbs up, subscribe, drop me a message. Thank you.